I think all of you have read the question. So a ball hits a wall with a velocity 10 meters per second and returns back with the same velocity, and the duration of collision in this period is 0.2 seconds. If the ball has mass 2 kg, then how much force is acting on the wall? How much force is acting on the wall? Mind it. So here force F equal to mv minus mu by t. Rate of change of momentum is the force. From second law we come to know about this. So this is a mass is 2 kg. Initial velocity was 10 meters per second and final velocity is in the opposite direction minus 10 meters per second. So you can write like this, minus 10 meters per second. This is the velocity when it returns back. Now duration of time is 2. Therefore force equal to minus 20 minus 20 minus 40 divided by 2. So it will be how much? Minus 200. Is not it? তাহলে এখানে আমি কি, what should I write? The rate of change of momentum of the object is, the rate of change of momentum of the object is 200 Newton. This is this one. Therefore, the object will apply 200 Newton force on the wall. But the force will act on the wall. The object will apply 200 Newton force on the wall. Okay. So if you are asked, an object is moving in this way, it reflects back in opposite direction with the same velocity, then just mv minus mu, there will be total momentum will be plus of the initial and final momentum divided by 10. Next, this is number 5. Go to the number 6. Number 6. If T1 equal to T1 equal to 45 Newton, find theta, and T2 equal to and T2. So you have to find two things. One is theta and this T2. Draw the figure PT. Should I remove the page?
Yes, sir.
Okay. Now this is 3 kg. T2. This is T1. This is theta. You are asked to find T2 and theta. Now you see, this is the weight and this is the tension. So this tension should have two components. You can consider one component along this another component along this. Now it is this is theta. It will also be theta. This is T1, sorry, T1 cos theta. And it will be T1 sin theta. Now, in equilibrium, T sin theta equal to the weight of the object. It is 3 into G. That is this T1 sin theta equal to 3 into G. Therefore, T1 cos theta equal to T2. Right. Now, what about 3G? 3 into 10. Therefore, sin theta by cos theta equal to 30 by T2. T1 is given. Here T1 is given. Then you can find, oh, sorry. T1 is sin theta equal to 30 by 45. Therefore, theta equal to sin inverse 2 by 3. This is one answer. T2 equal to T1 cos theta. T2 equal to T1. What about cos theta? কি করে করব? T1 is 45. Now how I can
স্যার sin থিটা থেকে cos থিটা বের করে নেব স্কয়ার করে।
ঠিক আছে, তাহলে sin থিটা যদি জানি, that means root over 1 minus sin square theta, 45 into 1 minus 2 by 3. That is T2 equal to 45 into how much is 3 root 5.
root 5.
Am I right? Right. Therefore, T2 equal to 15 root 5 Newton. 15 root 5 Newton. So your answer will be the tension T2 is 15 root 5 Newton, and T1 and theta equal to sin inverse 2 by 3. Okay. Now write a third question, number 7. Write down the question. If an object is allowed to fall, number 7. If an object is allowed to fall from a height of, I'm writing the question. If an object of mass 2 kg is allowed to fall from a height of 10 meter and it penetrates to a depth of 0 point, sorry, to a depth of 0.4 meter before comes to rest. Then find out the resistive force acting on the object by the ground. So what is the question is that if an object of mass 2 kg is allowed to fall from a height of 10 meter and it penetrates to a depth of 0.4 meter before comes to rest, then find out the resistive force acting on the object by the ground. What to do? First of all, you have to write, let the velocity of the object, before hits the ground is v. Let the velocity of the object before hits the ground is v. Therefore, from v square equal to u square plus 2as, from v square equal to u square plus 2as implies, what about v? We don't know. Whenever it is released from a height u equal to 0, 2, acceleration is 10 and the height is also 10. From 10 meter it is released, from 10 meter height. This is the velocity before it hits the ground. Now let the retardation of the object is a. Okay, Lokojit, very good. Therefore, from v equal to u minus 80, we get v will be 0 because after penetrating 0.4 meter, it will come to rest. So v will be 0. U is 10 root 2. This is about the equation This is 10 root 2 divided by 0.4. That is retardation will be 25 root 2. Am I right? Retardation will be 25 root 2.
Sir,
Sir.
T to your time na sir?
Yes, yes.
Sir, T to time. এটা তো স্যার
Oh.
ডেপথ বলেছে 0.4
Okay, okay. That formula we cannot use here. Very, very good, very good. Now, then it will be. So, what should I write? Which formula I have to select? This one. Am I right?
b square.
Yes. So it will be b square equal to. You 10 root 2 whole square minus 2a and 0.4. So 0.8a 100 into 2, na? So it will be how much acceleration? 2000 divided by 8. 250. So retardation will be 250 meter per second square. Therefore, a resistive force acting on the object F equal to ma. What about mass? 2 kg. Very good, Rohan. So it will be Lokojit already done it. It is F equal to 500 Newton. So your answer will be, therefore, the resistive force acting on the ball, due to the ground is 500 Newton. So this is about the result. Now let us move to the theoretical discussion of friction. So I think there is no confusion regarding this problem. Whether all of you are able to realize this? Ananya, Argodeep, Atanu, Chandrima. বুঝেছি? Okay. Next, the last question we have done. That was the number. কত number question ছিল last question টা? What is the last question we have discussed?
স্যার 7 নম্বর কোশ্চেন ছিল হোয়াট ইজ অ্যাঙ্গেল অফ রিপোজ
Okay. Now, next. Number 8. Write down. Write the laws of friction. Write the laws of friction. Write the laws of friction. So whenever we are discussing about the frictional force, we are considering an object is there which is lying on a surface. Now, whenever you are applying a force on this object, whenever you are applying a force on the object in the forward direction, there will be a force which is called frictional force in the opposite direction along the two surfaces in contact, and the weight of the object is along the downward direction, and normal reaction will be in the upward direction, exactly in the upward direction. In case of horizontal surface, it will be directly vertically upward direction. Now, laws of friction is telling that the frictional force acting between the two surfaces in contact, the frictional force is acting between the two surfaces in contact opposite to the direction of applied force. Frictional force is acting between the two surfaces in contact opposite to the direction of the applied force. That is, you are applying the force in the forward direction. The frictional force will act in the backward direction, but along the two surfaces in contact. Okay. First law. The second law. The force of friction acting between the two surfaces in contact is independent of the area in contact. The force of friction acting between the two surfaces in contact is independent of the area of the surfaces. Third, the frictional force is directly proportional to the normal reaction. You know, this is the normal reaction. Frictional force is directly proportional to the normal reaction. Therefore, F equal to a constant should appear here. You have to introduce a constant. That constant is mu, where mu is a constant and is called coefficient of friction. Coefficient of friction of the two surfaces in contact. Coefficient of friction of the two surfaces in contact. Therefore, mu equal to F by R. Okay, this is a very important formula. Mind it. Mu equal to frictional force by normal reaction. The ratio of the frictional force and normal reaction is called mu. Next, number 8 is laws of friction. Number 9, write down. Define coefficient of friction. Define coefficient of friction. So how you can define the coefficient of friction? Coefficient of friction between the two surfaces in contact. Coefficient of friction between the two surfaces in contact is defined as the ratio of the frictional force and normal reaction. Frictional force and normal reaction. Am I right? The coefficient of friction between the two surfaces in contact is defined as the frictional force and normal reaction. It has no unit because it is the ratio of the two physical quantities of same nature. So it don't have any kind of unit or dimension. Clear? This is coefficient of friction. Next, number 10. Establish the relation between the angle of friction and angle of repose. I think we have done it. Huh? Whether we have derived it. Establish the relation between the angle of friction and angle of repose. in the last class whether we have derived it or not.
No, sir.
No. Okay. Okay. Establish the relation between angle of repose and angle of friction. In our last class, we have discussed about that if a normal reaction is this one, this is the applied force, this is the friction force, then we can find the resultant. We can find the resultant of normal reaction and friction, normal reaction and frictional force, and the resultant makes angle theta with the normal reaction. Then this is called angle of friction, and from this triangle tan theta equal to BC by AB. BC by AB. You know, BC, this is the frictional force. This is F. And this is R. So tan theta equal to. Just now we have discussed frictional force by normal reaction is mu. So this is one relation between the mu and angle of friction. How we can define mu in with respect to angle of friction? Coefficient of friction mu is tangent of the coefficient of friction is mu is the tangent of the angle of friction. Now let us discuss about the angle of repose. What is that? If an object is lying here and the object is yet to slide, in that case, this is the weight. If this is theta, this is the normal reaction. This value will be mg cos theta, the component of this mg cos theta, and another component is mg sin theta. So this is mg sin theta, this is mg cos theta, and whenever the object will try to move along this, the frictional force will act in the upward direction along the inclined plane. Am I clear? Now, in equilibrium, what should I write? Who can tell me? In equilibrium, what should I write? There is we are talking about angle of, this angle is actually angle of repose, phi. That means this is such an angle.
F equal to mg sin theta.
Not about theta, phi. F equal to mg sin phi. Another, okay, very good. Another
R equal to
equation
mg
R
cos
equal
phi.
to mg cos.
Very good. So it will be F by R. F by R will be sin theta by cos theta. It will be tan phi. It will be tan phi. So what should I write? F by R, you know? F by R is what?
Mu.
Mu. Now, this is mu. This is also mu. Therefore, tan theta equal to tan phi. Now, what is the conclusion we can draw from this equation? What conclusion we can draw from this equation? Can anyone tell me?
Sir, angle of friction equal to angle of repose.
Right, very good. So, angle of friction and angle of repose are equal. Avik, Argodeep, Ankita. So, if you are asked, an object is lying on an inclined plane at an angle equal to angle of repose, that value is 45 degree. What is the angle of friction of that surface in contact? What should be the angle of friction of the surface in contact? Ek marks the question asked, that answer will be 45 degree also, the angle of friction. 45 degree as angle of repose, 45 degree with angle of friction also. Clear? So, this kind of numerical you may be given like that. Phi may be given, you may be asked to find mu. Theta may be given, you may be asked to find phi. Okay. Next, this is about the number 10. Establish the relation between the angle of repose and angle of friction. I think all of you are very much comfortable regarding this. If you have any kind of confusion, you may ask that I am not clear this one or that one regarding. Next, number 11. Number 11. Write down the question. Find out the acceleration of an object. Find out the acceleration of an object. Find out the acceleration of an object falling down along an inclined plane. Find out the acceleration of an object falling down along an inclined plane. Definitely, you must consider the friction here. So I'm just doing this theory very fast. Try to listen. So this is the inclined plane. You have an object here. So if an object is lying on the surface inclined plane, the weight is acting in the downward direction. The inclination angle is theta. This is the component mg cos theta. This is normal reaction. And this is mg sin theta. This is the frictional force. Okay? Oh, here, what language you have to write? Listen. Consider an object of mass small m is lying or is falling down along an inclined plane having inclination angle theta. The weight of the object is mg and the force acting on the object in the downward direction is mg sin theta. The force acting on the object along the downward direction is mg sin theta. As a result, a frictional force will act on the object. A frictional force will act on the object in the upward direction along the inclined plane, like this. So this is the object. The frictional force, the force acting on the object along the downward direction. Frictional force is acting in the upward direction. Therefore, the resultant force acting on the object, M1, F1 equal to mg sin theta minus F1 equal to, F equal to mu r. F equal to mu r. Just now I have discussed about r, mu mg cos phi. R is the mg cos phi. So F1 equal to mg sin theta minus mu cos theta. So this is the resultant force acting on the object along the downward direction. So what will be the acceleration of the object? Therefore, acceleration of the object A equal to force by mass. Force is this one, and here there is mass. Mass and mass will cancel out. It will be sin theta minus mu cos theta. This is the expression of acceleration of the object falling down along an inclined plane. Falling down along an inclined plane. So this is the expression of acceleration of an object falling down along an inclined plane. You just see g sin theta minus mu cos theta. You may be given a numerical like that. So an object is falling down along an inclined plane having inclination angle say 30 degree. And coefficient of friction is 0.2. Find out the acceleration of the object. Just g sin 30 minus 0.2 cos 30. This will be the value of the acceleration. It's very important. Is it clear to everyone? You may be asked, Dibbendu, listen, you may be asked, if an object is falling down along an inclined plane having inclination angle 30 degree, what will be the acceleration of the object? Given coefficient of friction is 0.2. Maybe you may be given a numerical like that. In that case, your answer will be g, g 10 meter per second square. Sin 30 minus 0.2 cos 30. Numerical regarding 2 marks may be given like that. Am I clear? Dibbendu? Okay. So let me take the attendance. Just wait. 1 second. Just whenever you are doing numerical, just try to memorize what are the different quantities are given. What are the different quantities are given? Try to memorize. Okay. And sometimes it may happen that a lot of quantities are given, but you are not sure which formula you have to choose. Now you have discussed about the object falling down along an inclined plane. The object falling down along an inclined plane. You may be asked, if an object is moving up along the inclined plane, in that case, what should be the acceleration? This is another question. You may be asked like that. So that's it. So listen. If number 12, find out the acceleration of an object moving up along the inclined plane. Same question, just it is moving in the upward direction. Now you think, whenever the object will try to move in the upward direction, what I have to do? I should apply a particular amount of force at first, which should neutralize this one. If I apply a particular amount of force to neutralize this one, then I will be able to make it static. Then whenever the object will try to move or it starts to move, yes, very good, look at it. Then a frictional force will act. That frictional force is acting in the downward direction. mg sin theta is also acting in the downward direction. So you have to apply such amount of force which can balance these two forces. Yes. Shodadeep Majumdar, very good. Now, what should be the applied force? At first, you have to consider an object is falling, moving up along an inclined plane. As moving up along an inclined plane, having inclination theta. If the object is moving in the upward direction along the plane, the frictional force will act along the frictional force will act along the downward direction. Therefore, total force acting on the object, total force acting on the object, mg sin theta plus f. It will be plus. Okay. It will be plus. So finally, this is the result. This is the result. Just the minus sign will be replaced by the plus sign. The minus sign will be replaced by the plus sign. Am I clear? If you have any kind of confusion regarding this derivation or whatever the discussion I am just making with you, you may ask, sir, this is not clear to me. You may ask. I think the previous formula is very much clear to all of you. This was the minus. Whenever it is moving down, now it is moving up. Now it is moving up. So it will be plus. Clear? Okay. So this is about the acceleration of an object. Whenever it is moving in the upward direction along the inclined plane. Clear? Now the last question. Then the last question. Number 13. Explain friction is a necessary evil. Explain friction is a necessary evil. Okay. Now, this is evil, but it is necessary. Then in that case, you have to write two things. You must write the advantages of friction. Advantages. As well as you must write disadvantages. What are the advantages we get? Friction is very much necessary during walking. Whenever we try to walk, if there is no friction, we will slip. On slippery places, on slippery floor, we cannot walk because there is no friction. There is a little bit of friction. That's why we are not able to walk. So whenever yes, Shodadeep, every kind of motion. In case of every kind of motion we write, we are in need of friction. During writing, we need friction. During walking, we need friction. Whenever a car is moving, we need friction. Okay. So in our every kind of motion, whatever the motion we are observing, friction is necessary. Clear? That's why it is very much necessary phenomenon. Now, what are the advantages? Disadvantages. Disadvantage is that if there is much more friction, then there is a wear and tear situation. All the machinery goods, all the instrumental devices are whenever there are friction between the two surfaces, there may be a depreciation. The longevity will decrease. If there is too much friction, power will waste. Like power will also waste. Energy will be lost in different way. So without friction, it is tough to move, to maintain motion. With friction, if there is so much friction, it is also tough to continue our daily life phenomenon. Decaying of tires. In case of friction, if always there is a huge friction appearing between the tire and the road, there will be depreciation of the tire, decaying of tire. So during friction, unnecessary extra heat energy will develop, which will also depreciate the substances whenever the two substances are come in contact. So without friction, it is tough to move, very, very tough to move. With friction, there is a huge amount of loss in energy and there is a depreciation of the different substances. Okay, so that's why as friction is necessary, as well as it also waste energy or power. So friction is called necessary evil. Friction is called necessary evil. We must maintain the frictional force, whatever the friction is acting, but we will always try to reduce the friction. In the next class, I will discuss about the different kinds of processes through which we can reduce the friction and other rest of the topic of this chapter. After that, we will discuss about the circular motion. It is also associated with this chapter, circular motion. There is in the circular motion, there are so many cases regarding friction. All these cases regarding friction we will discuss in our next class. Okay. So till now, what we have done today, listen. First of all, we have discussed about the laws of friction. The laws of friction we have discussed. Number one. Number two, we have discussed about the relation between theta and phi. Number three, we have discussed about the acceleration of an object. Moving along the inclined plane in downward direction as well as in the upward direction. Number four, we have discussed friction, advantage and disadvantage. Before that, we have done 3 numericals. Just try to recall them. I will try to send the video of the today's class. So read all these questions, prepare the note of these, and try to see a few number of numericals from your book. Okay.